and welcome to our next episode of Minerva PLM TV. I'm Jennifer Moore, your host, and today I've brought back with me again Bjørn Fidjeland of PLM Partner. Bjørn, thank you so much for joining me again today.
Well, thank you for having me again.
My pleasure. And Bjørn, last time we were together, we talked about digital transformation in the form of master data and the dictionaries and really getting your data in a good way. So, of course, that spurred quite a few discussions. It was really great. Our audience resonated with that topic. And so today, if you don't mind, I'd like to talk a little bit more about really giving that data context and structure. So beyond just, knowing that your data is clean and accessible, but going a little bit further into forming the basis of everything that you do next. So in your opinion, what really provides the most value? What should companies do with their data after it's clean and translatable?
Well, so you just asked me about one of my favorite topics, so I'd love to answer. Of course, accessible data is key, but even as important is to have data connected in the context it's used in, as well as quality assured, navigable, and comparable. In my view, data without context is sort of meaningless. If we take a look at different object structures used in a capital project and compare it with a model-based product development approach, you can identify clear similarities. However, it's not the structures themselves that bring the most value. It's the ability to connect objects from different structures together to reveal context and meaning across the life cycle that is really important.
That makes a lot of sense to me. And really in your blog about the European Spallation Station, you share a lot of diagrams, but one specifically on how they focus their data structure, including the functional breakdowns, the EBOM and the physical structure, and all the way to the installed structure as deployed, really. Talk to me a little bit about why this type of structure is effective and ultimately what it provides for ESS.
Sure. So first of all, European Spallation Source is by no means the only ones doing it this way. However, as they are a research facility, they have no commercial interests, and they're not in a competitive market situation. So they allowed me to write very freely about topics that for a global EPC, a product company, or an operator would be completely unheard of due to intellectual property and competitor considerations. So as in my blog posts, I really want to express my deepest gratitude to European Spallation Source and to Peter Rådal, head of engineering and integration department in particular, for allowing me to share all of it with you. Now, having said that, having information structured in the way the diagram shows for control and management of the data throughout the life cycle, this is because the functional breakdown structure, or a tag structure in capital facilities, lives from the early phases of design and evolves all the way through detailed engineering, procurement, construction and installation, commissioning, and ultimately operations and maintenance, all the way to decommissioning. And the real magic occurs when one starts to connect objects together from different structures to show in what context they're used. If we consider a typical operator's use case, then I could, as operator, easily identify all tags in a system, or the entire facility for that matter, that are centrifugal pumps. What their individual locations are, what design parts have been used to fulfill that particular tag's functional requirements, the physical asset that was delivered by a manufacturer and installed in the facility together with exactly what installation and commissioning activities have been performed, including issued certificates and calibration data of that asset for optimal performance within the design parameters of the system itself. So if we take a different viewpoint as a product manufacturer, There could be an example of, as a product manufacturer, I supply my product to many EPCs or operators in different projects worldwide. I have to deliver according to their contractual needs and regulatory requirements in a multitude of different regions around the world, fulfilling different tag standards and directives. So even if my product is 90% the same each time, my product documentation and delivery is always unique. So using a structured data and master data approach, that would allow me to build catalogs of my product designs who are generic, then pick them for use in a project-specific delivery, and then auto-generate the project-specific aspect instead of doing a 100% one-off each time. So using the structured and connected data approach, I would also be able to tell that if I've revised my product design to create an even better product, I can simply have a look at the previous revision to see all sites across the world where that product has been delivered, what function it performs in that site, and even data on each specific physical asset. So, I mean, imagine the sales department's opportunity. I mean, they could simply contact the operator of each individual facility and offer replacement or upgrades as part of that particular facility's maintenance program. Taking it even a step further, if sensors are used to monitor the asset's performance in the field, I could, as a product company, sell maintenance services in a completely different way, or even guarantee uptime as I constantly monitor and adjust to the health of that particular asset. But Jennifer, you've got extensive PLM experience yourself, so here it comes. If we compare the structures I write about to product development structures and the V model, do you have any immediate reflections?
Yeah, I mean, absolutely. It's one of the reasons why ESS is one of my favorite representations from your blog, because the similarities are absolutely transparent. You know, the way in which that ESS is deploying and managing those structures in the field at the research facility directly map back to, you know, the traditional V model of design in a product-based company. So it's very cool to see all of the same things that manufacturers are thinking about as they're putting, you know, products together and deploying them, that the companies that are consuming and using them are looking at them oftentimes in the same way, and then starting to be able to share information back and forth to really get into that service life cycle, like you just talked about, with, you know, guaranteeing uptimes or knowing exactly what's there to be able to replace it. It's really cool.
Yeah, I completely agree. And actually, that's one of the things that I find really fascinating, coming from product development as well from a PLM vendor, primarily in auto manufacturing industries. My home turf or background is also from capital facilities, energy projects. And it always struck me as, well, it's kind of similar, but the language is different.
Right.
And even when the language is the same, it means different things in capital facilities versus product engineering and serial manufacturing. So I actually have an example of it. Was in a major EPC. Head of product development was there together with head of plant and process. So for project deliveries. And they were actually talking together with the same nomenclature. The only problem is that in plant and process, it means different than what it means for product manufacturing. So they were agreeing, and then I kind of stepped back a bit and said, well, from product engineering, when you're talking about these things, you mean this and that and so forth, right? Yeah. And from plant and process, when you're talking about these things, you've got these pictures in your head. This is what you're meaning, right? Yeah. Is that true? They both said at the same time, and there was a huge discussion and a debate.
That's fantastic.
But of course, as we started to understand each other, we could iron out what the differences were and where there are similarities, and it became really great in the end.
That's amazing. And what a great example. And we keep talking about ESS like everybody knows what it is. And I definitely sort of fangirl out a little bit on the overall project because it's very cool, the research work that they're doing and how it's going to impact like the future of products and whatnot. But can we just like back up for a second? It's obviously a very highly technical example. This huge proton accelerator with a massive physical footprint. And I think it's really cool that even with as big as it is, and all the resources that they are consuming and the number of years that it's going to take to complete this project, that they're still looking to be carbon neutral, which is amazing and really forward thinking. But can you share with those that may not be as familiar with ESS, why it's instrumental in both industrial and consumer product development and all the areas that it has the potential to affect for the future of the way that products are manufactured?
Yeah, sure. The European Spallation Source is in essence a 750-meter long and 250-meter wide microscope. So the difference from an ordinary microscope is that instead of using light, ESS uses neutrons to conduct the research. So the neutron source will be the most powerful one in the world. So analogous to the brighter the light source, the more clarity and detail in an image when you take a snapshot. The brighter the neutron source, the higher the quality of the research and the more details are revealed. So with this microscope, you can actually reveal details of what's going on way below atomic level. But it is used in a wide variety of different research, which I'll get back to in a bit. But it consists of a 650-meter long proton accelerator, as you mentioned. And it accelerates protons to almost the speed of light before the proton beam collides with a target. So you crash the beam into a target. Within this target, the actual spallation occurs, where neutrons are flung from the target wheel to be guided through neutron guides to the instruments that allows researchers to do research. It's anticipated that 22 instruments will be installed in total, and each instrument is optimized for different kinds of research. So research will be as diverse as archaeology, biology, medicine, materials engineering, and geosciences, and particle physics, just to name a few. Examples that would benefit industrial, consumer, and product development would be along the lines of development of lighter and stronger materials, for instance. For life science, it would allow the study of biological processes that occur on the atomic to cellular scale, such as large macromolecular complexes, the function of water in enzyme mechanisms and drug substrate product binding, and the role of biological macromolecules in membranes. And these processes are represented in very diverse applications, all the way from biofuels to cancer research.
Which is so cool. I mean, it's amazing the work that they're doing. I can't wait to see, what really happens once they're able to get the research underway in a bigger footprint than it already is.
You know what? Me too. It's going to be really exciting to see once it's complete and in operation. And there is it's called European Spallation Source because it's European countries going together to fund this, but there are contributors from all over the world, actually. Mm-hmm. So we collaborate with research facilities from all over the world.
Mm-hmm. And it's, isn't it like partially underwater in Copenhagen, Denmark?
Well, actually, I don't know if it's partially underwater. Maybe some of the data centers are actually, I don't know. But it's true that the data center that gets all the data from the actual instruments. That's not in Sweden, that's in Denmark, outside of Copenhagen. Whereas the actual ESS facility is in Lund, in the southern part of Sweden. So it sounds like it's really far, but it's not very far, but maybe 50, 60 kilometers apart or something. But that's due to Denmark and Sweden jointly building ESS.
Very cool. And really their data structures are such a great example of getting to the next level, right? Whenever you start to think about the model-based approach and the feedback that includes that focus again on service lifecycle management, or SysLM, as Dr. Eigner likes to call it. But from what you shared, it doesn't really look to me like they're focusing too much on the 3D representations at this point. Why is that?
This may sound strange coming from someone with a background for development of virtual reality simulators, but the thing is, the 3D is one aspect of a digital twin or a digital transformation initiative, even for capital projects. A 3D model in itself is a fantastic means for a human to consume complex information and as an information carrier. But if the underlying data is not structured and connected, it will be impossible to extract the full business value and potential from it. As I mentioned in the article with respect to spatial integration, there is a full 3D model of the entire facility at ESS. It is in fact connected to all the information structures I described, including the functional breakdown structure. But in the article series, I really wanted to stress the importance of data in context. So worth to mention about the so-called EPL or ESS plant layout, which the 3D representation is called, is that it is a multidiscipline model, which includes conventional facility data, so building information model through IFC, industry foundation classes, plant and process, electrical and mechanical engineering data. So all disciplines are represented within the 3D model. So there's a lot of integration. This part of the model gives them the as design status, as the structure supporting the model is also placed under change control and release processes, the same way as for the information that resides within the other structures that are connected. The model is extensively used in our VR room for design reviews, for installation planning and training, etc. And in addition, there are the laser scans, which are constantly used to monitor our as-built progress on site. And they are then compared to the as-design model. And here the two models are placed on top of each other to determine any deviation so that corrective measures can be taken if it will collide further on in the project as we look at the project execution schedule. So it's not that the 3D model, or rather models, are not useful when embarking on a digital twin journey, but it is important to recognize that it is one of several aspects. When used correctly, the model can serve as a fantastic means to display information about other aspects as well. But without trustworthy information placed in context of other information sources, it would have a much more limited value. You can, in fact, have a perfectly functional digital twin without the 3D representation, in my view. An example would be that it might not be needed to have a perfect 3D model of all cars sold of a specific make and model, for instance. But it would be very useful to have the design data in a structured fashion and linked with each sold car's configuration data, again connected with data about all the critical physical assets that comprise the physical car. Software configuration and also runtime data from the car's sensors. And such a setup would allow for transformation of how services and maintenance is sold and performed on your car.
That's really good point. I like the fact that you point out that it's totally viable to have a digital twin without a complete total 3D representation, and keeping it in context, right? Because that's the most important part, is what value does it bring, at what level, where do you need it, how should it be connected, and what piece is it as part of your overall digital twin and digital transformation strategy.
Exactly.
So Bjørn, I definitely would encourage people to head over to your blog and read the series on ESS. I mean, there's so much information on this mega project. It's a really big topic, and there's just way too much for us to cover in one episode. But are there any other critical details or something that you'd like to share at this stage that that you think is important today?
Well, thank you for encouraging people to read the blog. Yeah, it would be along the lines of think big, dare to envision something great, and remember to get a buy-in from the relevant stakeholders in the company. Start small with identifying the key structures and capabilities, and don't forget the defined master data allows for interoperability across the information structures, and thus the full life cycle of a product or a facility. We talked a lot about that last time. Then scale the solution gradually at a pace that the organization can digest, and put a lot of effort into training. Because the technical solution can be completely perfect, but it doesn't really matter if it's not used by the organization. Be patient. This particular journey will take a lot of time. Remember to constantly harvest feedback from the organization as each part of the implementation is rolled out and put into use. This is just as important as the feedback loop you want to achieve by listening to the products operating in the field to find new service models and improvement of designs. And lastly, celebrate all the small wins along the way. It is very common to become impatient and feel that there is little or slow progress. But if you take the time to stop and look back at what has actually been achieved and delivered, you'll find that that would be, in fact, a lot, most of the time. And have fun. I mean, it's a spectacular journey.
Absolutely agree with you. I think that as humans, and oftentimes as, you know, really smart people that are involved in these projects from an engineering and IT perspective and taking on these big dreams, it's so easy to be critical and think about all that is still left to be done. So really taking the time to celebrate those milestones and cheer each other on to keep going, that's great advice. So thank you again, Bjørn, for being here today. I really enjoy our conversations, and I can't wait to see what we get to talk about next time.
Oh, me too. And thanks for having me. It's been great. Always a pleasure.
And to all of our viewers, as always, if you liked this content, remember to hit the like and subscribe buttons. If you have a question that you'd like to see answered on a future episode of Minerva PLM TV, either drop your comments below or send me an email at jmo@minerva-plm.com. Thanks, everyone, and have a wonderful day.